Welcome back. In this session, we are expanding our API system by walking through two vital backend challenges. First up is structs and JSON wrong keys on the wire. Instead of diving blindly into the files, let's use the DVL AI chat to methodically prompt engineer our way to the problem area, exactly how technical interviewers expect you to operate. First, let's open the AI panel and ask our initial discovery prompt. Where are the API routes and what do the data models look like for the books endpoint? The AI instantly directs us to API/books.go. Now let's follow up by asking, what do the tests look like for this module? The AI points out tests/books_test.go, warning us that the front end expects a strict data contract of snake_case JSON keys and explicitly requires an empty array, not a null value, when the bookstore collection is completely empty. Let's analyze the underlying concepts before writing code. Before fixing the bugs, it's vital to understand how Go handles serialization under the hood. Go's standard encoding/JSON package relies entirely on runtime reflection via the reflect package to examine the structure's metadata. By default, unless told otherwise, it marshals fields using their exact public Pascal case names. Furthermore, we must understand memory allocation for collections. In Go, declaring a slice like var books, book allocates a header whose internal data pointer is explicitly nil. While a nil slice behaves gracefully in pure Go logic, the JSON encoder translates a nil pointer directly to the primitive JavaScript value null. To satisfy strict API contracts, we must forcefully trigger a memory allocation to instantiate an empty, non-nil slice descriptor. Let's jump into the code to apply these principles. Zooming in closely on our structural type declarations inside API/books.go, we see our book struct uses standard public fields, capital ID, capital title, and capital in stock. Because they lack explicit metadata instructions, runtime reflection is dumping raw Pascal case keys onto the wire. Let's fix this contract precisely. We will append explicit struct tags using backticks. Right next to each field, we write JSON : followed by the snake_case keys in quotes, ID, title, author, year, and in _stock. This overrides the default reflection mapping. Next, let's scroll down to our collection endpoint handler, get/API/books. Notice the logic flow. The handler safely locks our store mutex, but then directly passes store.books to our JSON utility. If no books exist, store.books is an uninitialized nil slice, forcing the encoder to emit null. Let's fix this fallback logic. We pull the collection into a local variable called books and implement a defensive initializer check. If books equals nil. If that evaluates to true, we explicitly overwrite it with an empty allocated slice, literal using books equals open bracket, close bracket, book open brace, close brace. Now, when passed to our right JSON helper, it safely marshals as a clean, compliant, empty JSON array. Let's pull up our terminal panel, execute our Docker test suite, and watch the output. Fantastic. Every single test passes flawlessly with 100% full credit. We successfully secured our data contract using structured prompt engineering and solid Go fundamentals.